Good day, geometry. We are continuing with PO61, and on the first page of PO61, we got comfortable with simplifying roots, just the numbers, okay? Looking for those two perfect square factors, breaking them down as far as we can go, and then we even got into some roots of fractions as well. And at least to start, all of the denominators were perfect squares, and you really only had to worry about simplifying the numerator, okay? Today, we are moving on to variables. Okay, just when math makes sense, then we start throwing variables in. And so this is going to kind of complete the simplifying process. And so I've got several roots listed here. Square root of just x, x squared, x cubed, x fourth, x fifth, and so on. And just like we talked about with algebra before, right? We're going to take what we know, we're going to look for a pattern, and then extend that pattern into some sort of rule, so that no matter what the exponent is, you know what to do with it, okay? When it comes to the root of just x, x by itself, or n, or a, or whatever the variable is, this is in simplest form, okay? So the root of x is already simplified. You can't do anything with it because you don't know what x is. You don't know if x is a perfect square, you don't know if it's a non-perfect square, you don't know what, okay? So root of x is in simplest form. We're PERMDAS people. We've dealt with this before. The root of x squared, what happens with that root? What happens with the root and the power?
Cancel it out.
They cancel each other out. So what is the root of any variable squared?
X.
In this case, just x. Okay? So this is going to be just x. Because what happens is that root, I don't know what I want to put there. Nothing yet. Okay. What's that? So what's going to happen is, like, in x to the fifth here, there's no x squared there, right? So we have to know how to break it down so that we can do this. Just wait until we get through the chart, and then we'll see where we're at. Okay. Folks, here's where things get fun, okay? Because with the root of x cubed, just like when we had in yesterday's homework, or the day before, root 45, we found that perfect square factor, right? We would put root 9 times root 5, we broke it down, we got 3 root 5 here. It's important to know that the root of x squared is a perfect square, because for the root of x cubed, we can break that apart to be the root of x squared times what? The root of x. Why that works is because just like 9 times 5 is 45, x squared times x is
2.
x cubed. No, x cubed, right? X squared times x is not x squared still. Okay? We have 2 x's, we multiply by a third, that gives us x cubed. We're doing the same thing we did with the numbers, only now it's with variables. What times what is 45? One of them being a perfect square. That's where root 9 came from, and then times 5. What times what is x cubed? One of them being a perfect square. That's where the root x squared comes from, and then times x. If you've got a question, ask it now, because it's not going to get easier. Do you see where we got the root x squared and the root x from? Yes. Okay. So what is the root of x squared? X. Can we simplify root x any further? No. So x cubed simplifies to be x root x.
The x's are making it kind of confusing.
They're variables. It could be n. It could be y. It could be, right? It's just whatever the variable is. Okay?
What is the actual?
Simplifying.
Why would we ever need this?
Simplifying square roots. You likely will never need to do this. Do this again. I shouldn't say. It'll come up in algebra 2. It'll come up in geometry. But as far as doing it for a career, unless you get into the engineering field or the design, like computer design field, you're probably not going to use it yet. because the state says we have to teach it. I am in full support of nixing Algebra 2 as a required class completely and replacing it with like a personal finance course. I think that would be the smarter way.
Actually, that's so
Because
smart.
the percentage, oh, this is on, I'm being recorded right now.
Mr. Schultz,
Whoopsie
you're down
doo.
there.
Doesn't matter.
They're not gonna like this. Because the percentage of people that use Algebra 2 in their career is so small that if you need it, take it, right? But the percentage of people that would benefit from a personal finance course is 100%, right? It's just something that's gonna follow you throughout your entire life. But the state requires we teach what it says we need to teach, and so that is why I'm teaching it.
We love
Gives
the
Algebra
state.
2 that.
Video, we love this thing.
Okay, the root of x to the fourth.
If I don't calculate this mess, you're gonna.
The root of x to the fourth. What can we pull out of x to the fourth? What times what, including a perfect square, is x to the fourth? Eight.
X squared times x squared.
Very good. X to the fourth can be broken down to be the root of x squared times the root of x squared.
So it's x and x squared.
So it's just X squared.
Each of these, you know what, I'm gonna write this a little bit further to the left so I can write some more than right now. Yes, some of you are picking up on this. Very, very good, okay? X to the fourth can be rewritten as the root of x squared times the root of x squared, which each of these simply become an x because the root of x squared is a perfect square. And what's x times x?
X squared.
X squared,
I don't get the S third one though.
I guess I'm saying.
okay?
That actually makes sense.
So, x to the fifth. How many x squareds can we take out of x to the fifth? Two of them.
Yeah.
The root of x to the fifth is the root of x squared times the root of x squared times the root of what?
X.
Just x.
So it's x cubed.
It's not going to be x cubed
Oh.
because just like before, each of these become an x. And so that's going to give us x squared over here.
What?
What happens with the root of x?
It stays.
It stays. Nothing.
Oh yeah. My bad.
So the root of x to the fifth is x squared root x.
Yeah.
Okay? Let's just pause. Let's just pause.
Where's the other X?
This root x,
This is simple.
Two.
This is simple.
x squared, x.
Chris, why did you understand stuff?
This is simple.
Okay? But let's just look at the pattern here. Okay? When you have root x by itself, nothing happens because we can't do anything with that. We don't know what x is. When you have x squared, root of x squared, that equals x. Root of x cubed is x root x. X to the fourth is x squared.
I get it now.
Root x to the fifth is x squared root x. What would you predict the root of x to the sixth is going to be?
X cubed.
X cubed. Why? Because we can take out the root of x squared times the root of x squared times the root of x squared, which is how many x's?
Why did I put two?
Three of them.
Wow, Mr. Schultz.
What would you predict the root of x to the seventh is going to be?
X cubed
13.
times X squared, or what?
How about find a hockey?
X cubed times the root of x. The reason why is because for x to the seventh, we can take out the same three root of x cubed or x squares that we could before, which we know give us x cubed, but then that extra root x that we can't do anything with tags along.
Mr. Schultz, you get Avengers for this.
Okay? What would you predict the root of x to the eighth is going to be?
X.
X to the fourth. You are correct. Why is that? Because we can take out the root of x squared times the root of x squared times the root of x squared times the root of x squared. Because those are the perfect square factors we can pull out of this. Okay? Now, every time you see a variable, you don't have to do all this stuff in the middle. This is designed to show you what's going on to get this result. Now we want to come up with a rule, a pattern. What do you see? Audrey? Yes.
What are the numbers on the bottom?
These? These. X to the eighth, we can take out 4 root x squareds because 2, 4, 6, 8. Each of those root x squares is an x, which is where x to the fourth comes from at the very end. What do you see, Evan? Wow
The odd ones always have an extra X?
Yes. Whenever your power is odd, you're always going to have a root x taken along at the end. Okay?
Does that apply for the other ones?
That applies for any odd power. Any odd power, when you're dealing with variables, any odd power, you're going to have that extra root x at the end. Aiden, what else do you see?
I can't see. I can't read that.
Can you come up closer?
It's just two percent the handwriting.
Gus?
For every odd number, the answer is what it'd be for the number below it, tagging on that little X.
Okay, we're getting somewhere. What do you notice about the even powers? We'll start with the even powers. What do you notice about the even powers? James?
They go up by one each side.
Okay. Tatum, I heard you say
They're just half.
there's half. Whenever you have an even power, it's a perfect square because all the roots are simplified out. And it's just the exponent 6 divided by 2 is 3. 8 divided by 2 is 4. 4 divided by 2 is 2. Okay? So the rule is, for any even power, you divide. What's going on with the writing? Holy cow.
I think it's just you, Mr. Schultz.
I don't think so. I'm not.
It's not that bad of a writer.
I can't be that good and do that. You divide the power
What is that?
by 2. Okay? Your rule from the exponent is even is that exponent just simply gets divided by 2. Right? X squared, 2 divided by 2, is just x to the first. X to the fourth, 4 divided by 2, x squared. X to the sixth, 6 divided by 2, x cubed, and so on and so forth. So if you have something like x to the 100, the root of x to the 120th, that would simplify to be x to the what? 60th. Okay? That exponent gets divided by 2. How about when your power is odd? Evan already pointed out that you're going to have that root x hanging on there, but when we had x to the 5th, we had x squared root x. X to the 7th was x cubed root x. How are we going to know, like if we have x to the root of x to the 71st, we know it's going to have a root x at the end, but what's going to be in front? X to the what?
35.
How do you get 35?
70.
Divided by 2.
So you reduce, you subtract
By 1.
by 1.
Then divide
Yellow.
by 2.
Brilliant.
Really?
Okay, he is in either science or ELA.
Simple.
Yep, bye.
No, it would be,
Oh, yeah.
if it's somewhere in your class, Schultz, it would be not in science. It would be in history.
Thanks, James.
James, what are you?
It wasn't someone in my class.
Oh, the other class, that's ELA. What? The
It
other?
was a 7th grader.
Yeah, ELA.
Or science.
No, not science. They don't have science. They have
Oh,
science,
you're
but
right.
they have
Oh,
science.
you're right, James. Good boy. So the trick when a variable is odd, you first subtract 1, then you divide by 2, and then you always have to have that root x there as well.
Okay.
Okay? However you want to kind of write that rule out. So, I'll save these notes in case anybody needs them.
Whoa.
Really loud. For future reference.
I'm
Do you have Rowan?
Patrol officer number
No.
2.
Oh. Did she call you?
She's behind your desk. That's a pip. That's a pip behind your desk.
What is this?
That's the note.
Yeah,
from
she
the
wrote the
principal.
note. Love note.
Oh, I didn't know she put that there.
Oh, can
Yeah,
I read that?
this is getting ridiculous. I'm getting.
It's a love note.
Yeah, I
Maybe
brought
because
this
you're on
on
teacher
yourself.
probation.
Maybe,
Oh,
maybe
yeah.
don't tell 8th graders. Don't tell 8th graders.
What?
He's on probation.
They brought this on me.
Wait.
You
Oh,
didn't know that? You didn't know that?
They're survey.
You know that, right, Mrs. Smith?
We're recording. We can't get into too much detail.
He's on
Oh, you already went
The
into
FBI's gonna
detail.
find us.
Too much detail. Okay. So for the root of x to the 12th, what is that going to be? X to the 6th. Divide by 2, it's an even power. Simply divide by 2, and there we go. Skip 1. Over to X to the 17th power. What will that simplify to be? Evan?
Hold on.
You know it's going to have a root X.
LeBron's.
It's going to be X to the 8th root X. And again, where that 8 comes from, Emmett, right? Since it's an odd power, that extra X is just going to show up as root X, meaning we have X to the 16th. You subtract 1. X to the 16th, then divide by 2. That's your perfect square that goes up in front. X to the 8th root X. Yes? We will, yes. Okay? The last one, X to the 14th. What will that end up being? X to the 7th. Okay? Folks, the even power, simply divide by 2. Okay? The one we skipped over, that fraction, who remembers what the math hack is to divvy up a fraction when you got roots involved? Aiden.
Math.
Right. You can take the root of the numerator, so the root of y to the 9th, over the root of the denominator, 49. You can do that separately. Again, spirit of Christmas,
It's
that root of in the denominator is a perfect square. That gives you 7. So all you're left with really doing now is taking the root of y to the 9th, which you look at the variable, you see it's a y. You look at the power, you see it's odd. What is that going to break down to be? Evelyn.
Y to the 4th times the square root of y.
Good. Y to the 4th times the root of y. Okay, that odd power, subtract 1, divide by 2, that's where the 4 comes from. And because it's odd, you know you're going to have that extra root of the variable coming afterward. Okay? Questions? Questions on simplifying variables here? Because in the next row we put both concepts from the first page and the top half of this page together. When you have the root of a number and a variable, the root of 8x squared, we are going to treat these separately. We're going to split apart the number from the variable. Root 8 times the root of x squared. We just break it apart. Do we know how to simplify the root of 8?
Yeah.
We sure do. What are the factors of 8? 1 being a perfect square. 4 and 2. So this becomes root 4 times root 2, right? Which ends up being 2 times root 2. Okay, hold on. Okay, if you're lost, flip the page back one. We did this on the first page, right? Root of 8, you've got those 2 perfect square factors, 4 and 2. Now they're sending. Kidding. Root 4 times root 2 gives us 2 root 2. Evelyn?
Where did you get the 2 root 2? It's supposed to be 4 root 1. What?
No. So root 2 isn't a perfect square. Christopher, turn on. Evan. So root 2 isn't a perfect square. The root 4 is. Right? We got 4 and 2 because 4 times 2 is 8. The root of 4 equals 2. That's where that 2 came from. Root 2 we can't do anything with. The root of 2 is not 1, because 1 times itself is not 2. Okay? The root of x squared, what do we know that is now? X. So this breaks down to be, Christopher, stop turning around. Evan, stop messing around. Okay? He's gonna stop.
Yes, sir.
He's gonna stop turning around. You're gonna stop messing around. That'll fix that. Okay? So we have 2 times the root of 2 times x. That all gets put together with whatever's outside the root coming first, and whatever's inside the root coming after. So we have 2x root 2 as our final simplified answer. Audrey? Yes.
This is not fun.
Let's skip the next one and go to the root
This
of...
will be reflecting in my review.
He literally talked to me. I can't.
This will
Stop,
not be
both of you,
I told
or
him
you're
to
out.
look at the screen.
Stop,
was.
both of you, or you're out. This is the 3rd time in a matter of minutes.
Did I agree.
This is not. This
Okay.
is a serious topic.
Let's skip the next one. It's something that if you don't get this, the rest of the unit is going to be Your
Your chalk.
toast.
Chalk.
Luca.
How did you get from x squared to 2?
I didn't. The root of x squared, right,
Oh wait, yeah.
equals x. This 2 and this x we got from perfect squares. They're now outside the root.
4, 2. Oh.
So they go outside
Wait, why'd you connect them?
because how you would write this properly is to put it in the correct order. Whatever is outside of the root goes together, the 2 and the x. Whatever is still inside the root, like we couldn't do anything with this, right? That's going to be root 2 forever. And so then that goes on after. Okay. The root of 32 x to the 7th. We are going to start by breaking this up to be the root of 32 times the root of x to the 7th.
16 and 2.
Yep.
16 and 2.
Yep. That's
Wow.
right.
Everyone with me so far?
Good job,
No.
Mr. President.
Okay? Root 32, I heard someone say 16 and 2. Those are the two perfect square factors. 16 is the largest one.
What? 4 and 8.
8 is the simplest.
4 is the perfect square, but it's not the largest one. So if you use 4 and 8, you can break down 8 further. It is going to be more steps. So you should be looking for that largest perfect square factor, which in this case is 16. Evan?
So you should usually try to find the highest.
Yes.
Alright.
Try and find the highest one.
I have the answer.
Root 16, that breaks down to be
4.
4, not root 4, just 4.
I have the answer.
Okay? Root 2, we can't do anything with, so it just tags along. The root of x to the 7th becomes x cubed
X3. X.
Put the little X thing on.
root x,
Oh.
right? Because it's an odd power, you know it's going to have the root x, so you subtract 1, divide by 2, that gives you x cubed out in front, then the root x.
Jeez.
This is not.
Putting this all together, whatever's outside the root, the
Stays
4
out.
and the x cubed stays outside the root.
She's the crackers.
Whatever's inside the root, the
Goes-
root 2 and the root x
goes
goes together
together.
inside the root.
What?
And so this would be your final answer.
Oh, yeah.
What
That's
the
actual.
Okay?
Alright. I can do this.
Yes, Christopher.
If I didn't write it that way on the test, would it be wrong?
How would you write it instead?
The 4 times the.
If you kept it like this here?
Yes.
Yes, that would be wrong.
Wait, what?
Is that not
Yeah.
in simplest form?
It's not written correctly. It's like if you were asked to write an equation in slope intercept form, but you wrote it in like y equals b plus mx instead of mx plus b. It's not the right form. The correct form to write this expression is with everything outside the root together, everything inside the root. Yeah. So yes,
Let me write math homework. What does this cost?
45. 15 minutes. Questions on what we've covered?
You do the hard ones.
Yes.
Can we just work?
No. Well, you can
Yeah,
work
let's
if you want.
just
You want to
work.
go over the fraction ones.
No.
Okay? Alright, with the fraction ones. The root of 15x cubed over 4y squared. Again, we're going to start by splitting that up. The root of 15x cubed, our numerator, over the root of 4y squared, our denominator.
Oh, yep, for sure. So you just rewrote it?
Just rewrote it so you can deal with each one separately.
Oh, yeah.
Okay? We're going to start with our root 15x cubed. We're going to split this apart into the number and the variable separate. So this is root 15 times the root of x cubed. Can we do anything with root 15? No. We can't simplify it, and that's okay. Okay? Less work for you to do. You have questions? Okay? So this is just going to drop down, because we can't do anything with that. It's already in simplest form there. And what is the root of x cubed simplified to be?
X.
X squared.
X.
Oh, wait, hold on.
X square root of
X.
X root x.
Cool, yeah.
Or x to the first root x, right? Because you subtract 1, you get x squared. That's x the first, okay?
Is
Root
that
x.
3 or 2, like in the original equation?
What's that?
Is that a 3 or 2 in the original equation?
3.
I'm pretty sure I have this, but I'm not sure.
Pretty sure I don't have
Getting
this.
glasses.
Okay? So our numerator, when we put everything together here, we have x on the outside and root 15x under the root.
Okay.
Okay.
Okay?
Wait.
Got that. That makes sense.
So we're cooking.
Okay. Yeah, I have it.
So
That
actually,
kind of makes sense.
Evan,
So if it's not like captured by the root, it can go in front.
yes. Our denominator,
Kind of like,
I think I have the answer.
I got it.
our denominator, 4y squared, what is the root of 4y squared simplified down to be?
2y.
Root 4 times root y squared. I'm sticking with the theme of perfect squares for now, just because I want you to like me still. The root of 4 is
2y.
2. The root of y squared is
Y.
y.
so cute.
So our denominator is just going to be 2y.
Why?
Wait, so,
Oh, why? Like, why do we do?
Yes, James.
so I split it right at the beginning before you told us to do it your way.
Anything is no.
So I split every number
Did you get the correct answer?
and I got the correct answer.
Nice job,
So can
James.
I do
Excellent.
that?
Yep.
And it works?
Yep.
Okay.
Okay.
They start running when it's
The last fraction over there. Again, we're going to split this up. We've got the root of 25x to the 5th over the root of y to the 4th.
Can I answer it?
What?
Kind of
It's
simple.
easy.
It's kind of simple.
How about
What do you think?
I think it's 5x to the 3rd times the square root of x over y squared.
Oh,
X.
Oh, wait.
so close.
10 minutes?
When we break this up, our root 25 times the root of x to the 5th. The root of 25 is 5, the perfect square. Our x to the 5th isn't going to be x cubed root x, it's going to be x squared root x. You subtract 1 and divide by 2.
Oh wait, now I added 1.
Yeah, you subtract 1 and divide by 2, not add 1 and divide by 2.
Alright, cool.
Okay? So our numerator is 5x squared root x.
Got that one, right?
Our denominator, we don't really need to, I mean, I can write it out if you want to, but it's an even power. The root of y to the 4th is
X squared. Y squared.
y squared. And so this would be your final answer.
Yeah, that was really easy.
Okay?
Now the hard one.
Alright, thank you.
This is not.
Questions on what you've seen?
So.
I hope you're feeling smarter than you were when you walked in the room here. 'Cause
Yeah.
all of us have learned something.
So on the bottom ones, you just have like an extra one.
You just have an extra
Have you
pen.
learned from your probation yet or not?
Wait, what are you doing? Wait, what are you doing?
Okay.
Just do one.
Just do it.
That's, I wanna
Which
see
one
it.
of the 4
Pretty sure.
would you like me to do?
175. Pretty
Just so.
Just print off.
175. 174.
Let's see, Emily, which one of the 4 would you like me to do? 1, 2, 3, or 4? Great choice. 18x cubed y cubed. We're going to start by splitting this up with the numbers and each variable base separately. Root 18 times the root of x cubed times the root of y cubed. We deal with the root 18 the way we do any other number. We're looking for 2 factors, one being a perfect square. What do you come up with? 4 doesn't go into 18.
9
9 and 2. 9 and 3 is 27. Okay?
bad.
So root 9 times root 2, we have that perfect square factor, root 9, that gives us 3. The root 2 we can't do anything with, so that just comes down. What does the root of x cubed simplify to be?
X root X.
X root x. What does the root of y cubed simplify to be?
Y root Y.
Y root y.
Oh, I'm on fire.
And so now to put everything back together,
Can you combine the Y's? X's and the root?
yes, everything that's under or not under the root, or what do you say, not captured by the root, anything outside the root goes together outside the root, which would be a 3, an X, and a Y.
What about 3x, y?
Okay? Everything that is captured by the root, or is under the root, goes together, which would be 2x, y.
It's actually kind of simple.
And that would be your final answer.
These ones look the hardest to consider.
Yes,
So if they are captured by the root, they can go together.
yes. They band together in one root cell.
Like that.
One root. Yes.
Feathers. Birds of a feather stick together.
Okay?
Birds of a.
Questions, or you think you might be able to do those last 3 on your own?
Got it.
I think you can do ChatGPT.
Give it a try. Don't use ChatGPT for this. You can't use ChatGPT on the test. Okay?
Goth AI or?
You can't use that on the test. So I mean,
True.
and this PO61 has 12 questions to it, and so you really need to know how to simplify roots. You will not be able to fake your way through it. Oh, I'm still recording. All right, this is due on Tuesday because Monday you've got your math test. Likely see some of this stuff on there, so it's very timely. But that is how you math.
Don't forget to
Why?
Don't